Today I want to talk a little bit about numbers. We encounter numbers all the time in our life, and it is often hard to really know how to interpret them in the right way. And frankly, for a lot of numbers, you actually need a somewhat deeper understanding of the processes they describe, and also of mathematics, statistics, and probably science to understand where they're coming from. But there is some general rules we can follow just when we encounter a number, how to deal with it. The first point is always try to understand what is the source of the number. Is it a number which was obtained by a measurement, like for example the height of a person? Is it how precise was the measurement? So did someone just estimate it? Then it's not very precise. Did someone use a yardstick to measure them, or did they use maybe even laser precise measurement methods? All those will give you a different precision, and depending on the circumstance, this is more or less useful. If you just want to know the rough height of a person anyway, then of course you don't need to have it measured down to a millimeter or even better than that. But for example, when you're working on a high precision instrument and are trying to calibrate it for something, then this might be actually quite useful to have such a precise measurement. Some numbers we encounter are kind of made up, some of them quite obviously. Often they're more used to tell a story. For example, there is a meme, I guess, I encounter once in a while where it says something like, "Men think about sex every 10 seconds or something like that. And of course there's no way to make such a statement about all men, or even to find out such a number with a single person. So it's more about a story someone wants to tell. So just take it as a story. If you don't agree, you can point out that this number is obviously made up, but you don't need to really put much more thought into it. It's a bit more complicated when we encounter numbers which come from a scientific background, or from numbers about the economy or things like that. Then it is often good to try and do two things. First, try and find out how this number was created. If sometimes the math is too advanced for you, at least try to find out who created it, in what circumstance was it created. If you have sufficient math knowledge, you can also see if you can find out how it was actually measured, if it was calculated from other measurements, how this calculation was done, were the numbers used for the calculation, were they just guessed, or were they actually obtained with some measurement? How does the measurement method work? How precise is it? What assumptions go into it, and things like that. This, of course, again requires that you have a certain feeling about things like statistics, but it is actually something, if the more you do it, the better you'll get. So if you just decide to look a little bit more into numbers, just start with it. Don't think that you are already great at it, but just do it more and more to get a feeling for it, and over time you will get a better feeling for how to judge those things. There's another thing which you also, when you're talking about numbers based on a measurement, this includes numbers which are calculated from other numbers. So if there's an imprecise measurement and someone calculates a number based on such an imprecise measurement, the calculated number will also be imprecise. Actually, there is ways to quantify the precision of a number that you have. It is things like, if you have like a graphic representation, that would be something like error bars. In my studies of physics, we always had to put in a measurement arrow when we made a measurement, which basically was our certainty on how precise the measurement we did was. And if we calculated a number from this, there's a certain mathematical rule how those errors translate into the errors on a resulting calculation. There's another kind of error, which is a statistical error, where you measure something which is spread out due to some statistical distribution, and so there's a certainty that you will find a number at a certain value, but due to the nature of it being spread out, you can actually calculate that the number actually shows you more of a range, and then you can say, okay, a number I measured, it's based on ideally more than one measurement, and then you do some statistics, and then you can say, okay, what I measured is most likely a certain number, but I have an uncertainty which is spread around it, and there's certain rules how I can describe this. Usually this is done by something called the standard deviation. I'm sure you find thousands of videos on this on YouTube, so I don't think I have to record one of that, but you might want to check out what exactly it means to just get a feeling how to deal with numbers based on statistics, so that you're just aware of what it actually means. For example, considering errors, it's basically errors and standard deviations. It's basically considering uncertainties in numbers when you look at them, and it might mean that you have two numbers which are different, but they also have an error. They have a measurement error, or they have a standard deviation because it was statistically obtained. And then you can look at the numbers, and you might see that actually if you look at the range, which is set up by the number plus the error and minus the error, then you get kind of like an interval of numbers, so a certain area in which the numbers are situated, and you might find that actually those intervals for the two numbers you're looking at usually overlap, even though the numbers are different. And that actually means that if you include the uncertainty in the numbers, you actually cannot decide if they're different. Often when you read some news representation, people will not give you the errors. So, well, it's kind of hard to actually interpret the numbers if you don't have this. Always keep this in mind. If you have a real scientist talking, you might notice that a lot of scientists in their statements are always somewhat careful. Many of them will always point out that there's uncertainty in what they're saying, and that they're only talking about the current level of knowledge, and that is because they're aware of such errors in their measurement, and they know that they need more measurements to actually know what is a fact, or to be closer to describing the actual facts. That also means if you see someone making a statement where they're absolutely certain about a number, unless it's a mathematician who does pure math, which is basically done out of its own logic, you should always be careful, and you should say, okay, let's check out how does he arrive at this number, and is there actually a way to arrive at this number, or is he probably driven by some political opinion or by some other ideas which are not really objective and scientific? Because, as I said, whenever you measure a number, whenever you calculate a number from a measured number, there is some uncertainty. There is scientific methods to have very low uncertainty. If you go to particle physics, they are so precise in their measurements that it's unbelievable. But they're never 100%. There always is a certain degree of uncertainty, even in the best measurements we can do. And you can, just as a general rule, if you move to biology, if you move to society, to economics, social problems, this uncertainty increases. This is for practical reasons. If you want to measure the properties of something like an electron, you can do it 1,000,000 times without any problem, because there's a lot of them around. It's very easy to do an experiment with a lot of them. Well, might be a big instrument, but once you have the instrument, it doesn't matter much if you do it with one or with 1,000,000. And they don't really change from one to the other, so it's easy to normalize them. And finally, no one really cares how many electrons you smash against each other. On the other hand, once living beings are involved, animals, plants, and of course people, things get much more complicated. For one, we are not all equal, so it's much harder to find general properties over all of us. And there's much more things influencing our behavior, which then also will influence the measurement. And of course, there's also moral reasons to not do certain kinds of experiments. So you have to find workarounds around it, but they mean that the numbers are also much less precise. So you can say that those numbers carry a larger uncertainty with them just by nature. That doesn't mean that you cannot have clear statements based on those numbers. If you compare two different numbers and they're very far apart, depending on the error bars, then of course that allows you a decision. For example, if you say, okay, I think that a certain economic fact should happen, and then you can say, I predict that something will increase the GDP, for example, and then you say, I think it should increase it by 100%, and then there's a number which you expect if this is done, and if it's done and you don't see that number, but instead the GDP reduces, then your idea was probably wrong. Unless you had a really huge error in your prediction, but then it's kind of pointless anyway and you don't need to make it. So try, whenever you see numbers, try to see how much is the certainty of this number. You might find that, for example, in an economic prediction, that actually the uncertainty in this prediction is so big that it's kind of pointless anyway, and if the person who does the prediction doesn't mention this, maybe it's more based on a ideological point or wishful thinking or incomplete understanding of the numbers. You might find someone made a prediction and it didn't come true. Then also check out how does the person react to it. It's actually completely fine to do incomplete or wrong predictions as long as you check how good your prediction was and then change your method to make better predictions in the future. This is kind of like the way science is done, and this is also what, in a way you could say, how wisdom is gained in general, not only with numbers. So I hope this was a good first primer for you on how to deal with numbers. Take them serious, but try to understand them. When you see a statistic, try to understand how it was created, because otherwise you will not be able to understand what it really means. See if the person that gives you a number has themselves the understanding of the number, and then you should be fine. And start learning to do this right now, because the more you do it, the more practice you have, the better you will get at it.